Hello, I'm Rohit Gele, and on behalf of Group 5 from the Department of CSE Cybersecurity, we are here to present our project title, A Behavior-Driven Approach to Insider Threat Detection in Organizational Systems. We are a team of three, including Nidhi Chandurkar, Piyush Bawaskar, and myself, and our guides are Dr. Deepika Ajalkar ma'am and Dr. Arti Patle ma'am. Let's start by defining the problem. What exactly is an insider threat? Is It's not some external hacker trying to breach a firewall. It's the moment a trusted employee partner decides to misuse their legitimate access to compromise the organization data or system. This makes them uniquely difficult to spot because they are using legitimate credentials. Traditional static rules like don't open attachment are useless against adaptive behavior, such as malicious admin slowly exfiltrating data over months. The consequences are severe, and as you can see in chart, while negligent insiders remain the largest cause, the risk for malicious activity is suddenly increasing. This danger is why we need to move beyond simple rules and find a smarter and more adaptive solution. So in problem statement, to build a better solution, we first identify the four major gaps in current detection method. The very first is inflexibility. System rely on fixed predetermined rule. They are only good at spotting threats we already know about. They fail completely against new or novel attack method. The second is inadequate context. Current tools often analyze and employ action in isolation. They don't consider if that behavior is normal for their role or their team. This leads to an intolerable high number of false positives and quickly fatigue and overwhelm the system security. The third we face is the limited real-time capability. Many platforms rely on batch processing of logs. If detection takes hours, the malicious insiders has a grace period to complete their objective before the system even flag an alert. Fourth is limited explainability. If a sophisticated machine learning system flags an alert but the analyst cannot understand why, they lose trust in the technology. We need to open the black box to ensure our system is auditable and usable. Now the proposed solution and the core novelty. Our solution is a unified behavior-driven system designed to solve these four shortcomings. Our core novelty is the integration of three critical layers into a single framework. Multi-layered anomaly detection. We combine three complementary types of analysis: statistical, behavioral, and contextual, to get a complete risk picture. Then we added the analyst focus explainability (XAI). We embed transparency into the alert, ensuring security team understand and trust the result. And the third is the enterprise-ready governance. We build we build in a crucial feature like privacy control and real-time performance for from day one. Hybrid machine learning breakdown. In the hybrid machine learning engine, we don't rely on just one model. We use three specialized detectors that work together. First, the statistical detector uses isolation forest. This is fast and effective for quickly spotting simple and global outliers. Second is the behavioral detector uses an autoencoder framework. This is crucial for catching subtitle, nonlinear deviations, the kind of sophisticated user behavior analytics that a basic statistical model would miss. And the third, the contextual detector, uses graph-based indicators. This monitor relationship. For example, a user accessing a resource they have never touched before, or suddenly interact with a different set of peers. The raw score from these models are then combined in a calibrated fusion layer. Most importantly, this layer implement our solution to the high false positive problem. It implies peer context normalization and uses adaptive threshold. This ensures that if the entire HR department suddenly start accessing a new tool, our system recognizes that as a normal group shift, not a single user anomaly, keeping the false alarm extremely low. Now, in system architecture, we propose a machine learning based system using isolation forests, autoencoders, and graph neural networks. It continuously monitors user activity logs like logins, email access, and file usage. When anomalies are detected, the system generates a risk score and alert analysts in real time. A prototype includes fast API backend, React dashboard, PostgreSQL database, all containerized with Docker for scalability. A prototype system that works end-to-end, an agent generates user activity, the backend analyze it for anomalies, and the frontend show risk in real time. First, events like login, file access, USB usage, or unusual network activity are sent to our backend. In this demo, we use a simulator to act like a real endpoint agent so we can safely generate realistic behavior. When we run anomaly detection, we turn events into feature and use a hybrid pipeline. An autoencoder flags behavior that unlike the user norm, and graph analytics spots unusual relationships. We fuse these into one risk score, tune thresholds by department to cut false positive, and attach clear explanation so you know why a score is high. Finally, the front end shows everything live. On the overview, you see live stat and the top risky user. The activity feed on the right updates instantly as event come in. Jumping to the user, this table contains everyone with their current risk and trends. I'll open a user. At the top, you see the risk timeline. Below our explanation, XAI show which feature drove the score. The autoencoder highlights unusual behavior and graph insights flag uncommon relationships. In alert, analysts get a prioritized queue. Opening an alert show the reason, the signal, the link straight to the user and investigation. Finally, settings let us safely tune threshold, peer sensitivity, and retention. Changes apply immediately to new events. Now, looking at our most compiling result, uh, we validated our system using a simulator that generate 1 lakh streaming events to ensure realistic condition. And this is the table showing the model accuracy F1 score. Now conclusion. To summarize, we have successfully developed a unified behavior-driven pipeline that combine multi-layer detection, contextual fusion, XAI. We achieve superior detection quality with a low false positive rate of 0.08 and maintain a real-time performance. Contribution is the engineering integration that transform advanced algorithm into a trustable, fast and deployable framework. Thank you.